Okay, hello. Um, I'm gonna do a video about some file processing in Azure. And I'll start with a diagram, because that's probably the easiest way to do it. So here's kind of what we're gonna do. We have a CSV file coming from an external source, and you need to stand something up to process it. So this box represents a processor. And what we're going to do is we're going to use some Azure functions and some Azure services to process it, essentially. So we're going to be using blob storage. That's kind of how the file's coming in. It's going to land on blob storage. We're going to be using a couple of Azure functions to process it, in air quotes. And somewhere in the middle, we're going to be using queue storage. So I'll go through this a little more sequentially. The CSV input file will be coming from an external source and landing on my Azure blob storage. Normally, you would use a blob trigger here that will fire when the file shows up, but there's some constraints that I'm under that I'm unable to do that. So I'm using a timer trigger instead. So this function will run on a schedule. It will periodically check blob storage for the presence of this file, and if it's there, it will process it. And by the way, this is just a demo that I'm putting together. It's not production level code by any means. Once it processes that file, reads each line of the file, it will push it. It'll call send message and send that to a queue in a JSON format. Once it's on the queue, my queue trigger will get invoked, and it will pick up that JSON block off the queue, put it back into a Java object again, the same Java object that this was in the first place, and it will use those values to call an external API. So that is the crux of it. So I'll just put that back there. Now, I know this is a bit of a weird use case, probably only appropriate for smaller volumes, but this is the situation that I'm in, and the volumes are small. Some scope. This is going to be showing local only. I'm not actually going to be deploying it to the public cloud. And it's going to be Java, which is a little bit different than C#, which is what you would normally see these demos done in. Okay, so the tooling. Let's talk about the tooling. I'm obviously, you can probably tell I'm on a Windows machine here. I'm using VS Code. VS Code as my editor. Oh, having trouble getting it up here. Here we go. And of course, you can just download that for free from Microsoft right here. I'm using a couple of Azure extensions as well. So let me show those. So one of them is actually called Azure Functions. This might be the only extension, actually. And what this thing does, the most useful thing that it did for me is it allowed me to create a new Azure Function project, VS Code compatible Azure Function project, which is kind of nice because then when you're reading this thing into, if you want to share it or whatever, the Azure VS Code project will automatically recognize it as an Azure Function project, etc. So, and it has other functions like you can create a new function with this too. It gives you like some scaffolded code essentially. So, and another thing I'm using here is I'm using Azure Core Tools. So here I'm on the page on Microsoft for Azure Core Tools. Azure Core Tools is essentially the equivalent of a lot of the Azure functions that you run in public cloud, especially the compute and the storage, whatnot. Not the storage, actually, more the compute. And that's what I'm using it for the Azure function emulator, which is what I really need. Also, I'm writing something called Azurite. So here I'm on the page for Azurite. Azurite is an emulator. This is the emulator for the Azure Storage. You need Node for this. So you need to install Node. I'm not going to get into that. And run an npm command to install it. And it's got that right here. And I just run, after that, you can just type Azurite on the command line and it will start it up. I am using PowerShell and it seems to work fine. And the last thing is you need something called Azure Storage Explorer. So let me put this up for a second. It's here. So this is a pretty nice tool, and it allows you to connect up to all of your Azure Storage accounts and see what's in there, see what files are in there, what records are in there, what have you. As you can see, I'm using the emulator part of the tree here. That's built in. It just knows that I'm running an emulator, picked it up, and here's some files here. So I'm using blob containers, queues. I'm not using tables. And I assume if you are using actual Azure storage in the cloud, it would use that part of the tree. And so this, while we're here, this is my input file. So it's in this container called landing zone container, which I created. And I refer to in my code, and I'll just open it up, and I believe it's gonna open this thing in a spreadsheet. I'll go, because that's what it does. So that's fine. Just imagine this is a regular CSV file. It's just using a spread. It's not a spreadsheet. It's just a spreadsheet's a easy way to view it. So you'll see I have 3 columns essentially. The first column represents like an ID column. Second would be a name. A third is supposed to be like an account number. So remember, this is just demo code. All of this is demo code, so not very realistic. But you know, your record may have 20, 30, 100 attributes, and maybe thousands of lines. Okay, so we'll just close that. And there's another file here called airconfig. I'll get to that later. Okay, so not to hit you over the head with it, what's the strategy here? Why, you might wonder, why are we doing this? Why do you have such a complicated, all this workflow happening? Couldn't you just have one Azure function that reads the file and calls the API? And you totally could. There are a couple main reasons why I split it up like this, and the first one is, again, I'm not exactly an expert. I'm new to Azure Functions, and I haven't done a lot in Azure necessarily, but my understanding is that these Azure Functions are meant to be running as short as possible to do as little work as possible for each invocation. So if your Azure function were to read this file line by line and start calling the API for each one, you could run into some potential issues. The first thing you're going to have to make up your mind about is, are you going to be blocking on the API call? Because, you know, if you're not blocking on the call, then you have to call it asynchronously, and you just fire all the API calls off one at a time, and then somehow you have to like figure out if they were successful or not after the fact, which I'm sure you can do. But if you're going to block, then that means it's going to take a long time. And probably the biggest thing that the reason I like to do it like this is because I'm worried that if the API might fail, and perhaps fail partway in between, I like the idea of splitting up the work and pushing it onto a queue. And that way, what's processed is processed. What isn't isn't. If it fails, there's a retry mechanism that we can use. That's pretty robust. That's built into queue storage. That I think is a big advantage. So the retry is really kind of the big reason why I'm doing it like this. And again, I'm new to this, so put in the comments. Go ahead, feel free to put your opinion on this. Okay, so that's a little bit on the strategy. Now, so I'll show the actual code now, just very briefly. There's no rocket science going on here. So I mentioned I have 2 triggers. I actually have 3. I'll get into that in a second, but I'll show the 2 that I talked about first. So to process the file, this is my trigger to process the file. So this is my timer trigger. And you can tell it's a timer trigger by the annotations, and it uses annotations quite a bit. And this is the schedule that I referred to. So I'm not going to get into the exact syntax here. There's lots of docs online, but essentially this is currently configured to run every 5 minutes. That doesn't match my actual use case, but that's just for my demo purposes. I have it running every 5 minutes, but you can play with that. So it gets called. You don't get anything when it gets called. There's no information coming in on a timer trigger. It's just you start going at it. So the first thing we have to do is we have to get our connection string so we can set up our blob container, our blob client, basically. So you'll see this thing here where I'm getting the system environment variable or something called Azure Web Job Storage. So now I'm going to go to a file here called, this is a configuration file called local.settings.json. I just knows to look for this file. This was generated for me automatically. As I mentioned, I used the create project, it created this for me. And I have the Azure Web Job Storage configured to use local storage right now. And I haven't gotten too much into running. Like I haven't tried this on the cloud yet. So this is about as far as I've gotten. So I won't be able to actually say how you switch between the two, but I'll figure that out later. So you take your connection string here and you start creating what they call a blob client using a builder pattern. Now, once you created your blob client, you need to name your container. So in Azure Storage, it's a pretty flat hierarchy, but you have containers and you have files in them. So my container, I just called it landing zone container. And this is the file, raw input.csv, the one you saw earlier. You download the content, you stream it. You get into some fairly generic code here that is going to read through that stream using a CSV reader. I won't go too much into this because if you just Googled CSV reader, you will find this type of code, or if you used an LLM, it would generate this type of code. But what it's really doing is it's parsing out, it's looping through all the lines on a file. It's getting my individual fields, so it's getting my ID, it's getting my name, and it's getting my account number for each row. And then it's going to create a JSON. So I'll just quickly jump into here. So it's just a little local function, creates a data record. So this is my POJO essentially, and that's this right here. So that's my invention. Calls the setters for each of the attributes, and it calls another little function here, which uses Jackson, as I mentioned earlier, to convert the POJO into a JSON string, of which we will. So I'm on this line here now, line 69. We will call the send message on to push it to the queue. So this is a method here, a local method to push to the queue. So you'll see a very similar setup here as we did for the blob client, except this is called a queue client. You get your connection string, which again is local, the name of the queue, which I've named live queue, and builds a queue. Now, by the way, I had a lot of trouble with this. It wasn't working. It was failing a lot. I had to I had to add this instruction to tell it to base 64 encode things. I'm still not sure why. In my opinion, I shouldn't have had to do this, but if I didn't do it, it would not work. I don't know if that was a function of running these local emulators or not. I'm not sure, but for now I have it turned on. But this is something to look out to if you are using these things. A queue, for instance, and you're pushing what you think is a fairly normal string, and all of the method attributes just take string. You think you would just push a string on and just pop a string off and it would work. It should, but it doesn't. And finally, you build your queue client and you call the send message to actually send it. So that is the first trigger. The second, this is the queue trigger here. So once again, you can see it's a queue trigger because it's marked up with an annotation telling it it's a queue trigger. And this is part of the same thing that gives it the function name. This tells what queue you're listening on. This is your connection string. And message is the name of the variable that'll be populated with the payload off the queue. Everything on the queue should be a string, as I mentioned before. So it takes the string. It's going to convert the string back into the same data record class that I had in my other trigger. Now I'm going to call an API. So here's a little local method to call an API. This is very basic code. This is code that, again, you can have an LLM pump out for you. That's how this was created. You create an HTTP client, setting some attributes here, including timeout. You take your data record, in this case, I'm just going to put the data record in the body. Now, in reality, if you're actually calling a real external API, you probably need to convert this into the appropriate format that the API is looking for. I don't do that. I'm just going to do a post, and I'm going to dump the body is basically going to be my JSON again. So again, this is a demo. That's why I can get away with that. But there would be normally some translation going on here. Here we are calling. This is where my third endpoint is coming in. You're going to see I'm hitting localhost mock. So what I decided to do was I thought, well, I'm using Azure Functions anyway. Why don't I make a mock API to simulate the real API because I don't have access to it, and do it like that. And I use an Azure function for that called an HTTP trigger. So I'll show that in a second. Get the response and finish, essentially. So here I'll very quickly show my mock API. So this is the third trigger. So as you can see, this is an HTTP trigger, Azure function as well. It has some attributes. This is, accepts a get and a post. I'm going to be using the post because I need that's most closely matches my reality. And the rest of this is, pretty standard. It's just, it's not really doing anything. It's checking for the presence of something called name, if you call the get, or if it's checking for the presence of a body, either way. And if it gets that, it will just, in the happy case, it'll just echo that parameter or whatever you pass in the body back at you. Now, you'll see something here. This is something that I created, and I'll explain later, where it's checking something called an error configurator. And if it's set to on, it'll actually return a 503. It will fail. And I'll be using that later, and when I'm kind of demoing some of the retry stuff. Okay, so those are my 3 triggers, and that is the code. So retry. Retry is interesting, and if you start Googling around about retry and Azure functions, you're going to find a lot of information that may or may not be documented that well. But essentially, what I found and what took me a while to understand is that I actually had 2 choices for retry. So let's go over what those choices are. Now, when I was showing the queue trigger before, you may have noticed that I have a couple of things up here, a couple of annotations commented out. One of them is an exponential back-off retry with some parameters, and another is a fixed delay retry with some parameters. And I actually I'm a big fan of exponential back-off retry, so this is the thing that I tried first. But what I didn't understand was that this has absolutely nothing to do with the Azure queue function retry mechanism that's specific for queues. This is a more generic retry mechanism that it's appeared to come out in 2022 from what I can gather. It's written for, this is more generically for Azure functions for retry. So there's different functions that do different things with different services, like a service bus, etc., or maybe a Cosmos database, etc. These strategies will work with a lot of different things. Now, so be that as it may, I still thought that maybe this was probably for me, and I gave it a try, and I configured them, and I tested these things out. Now, but what I found, the first thing I found was when I was using these annotations here, this style of annotation for retry, I found out 3 things actually. The first thing is that it appears to block other messages that were already in the queue. So in my case, I only had 3 records in there, and it started failing on the first one because I made it fail on the first one. So it's failing, it's failing, it's failing. And in the meantime, nothing else is going on with ID number 2 or ID number 3. So you may or may not think that that's a good idea. I can see some people arguing that it might be a good idea to just, delay trying to process everything, because if the API is down, then what's the point? But we know that an API being down is hardly the only reason it might fail. It could be bad data, which is another reason, in which case you don't really want to hold back the whole loot just because one of them, you have one bad apple, and I didn't particularly like that. Now, I don't know if it's something that I was doing wrong, etc. I'm not too sure. Another factor, of course, is that I'm learning that these triggers don't just get one record at a time. They get them in batches. So, and the batch size can be configured. So, because I only have 3 records, of course, it's probably getting them all in one batch, not allowing, for instance, maybe another process to pick up another instance of this reader, etc., to another thread to go pick up the others. But perhaps, you know, it would only hold up a batch of them. I'm not too sure. But even at that, I didn't even like that aspect of it. And the other part is that it appeared to be ephemeral. Like when you retry and you fail and you're waiting, and you know, depending on how you configure it, you can be waiting a fairly long time, especially with exponential Vekov. It is not really recorded anywhere. There is no record of it. It's really an in-process thing. There's a little bit of a lack of observability for me. I didn't see anything obvious in the logs either. So I didn't really like that aspect of it as well. The third thing that I learned about these particular, this style of annotation, this type of retry, this implementation of retry, is that it works in concert with the retry on the Azure Q Storage as well. So just to give you an example, to say what I'm talking about, let's say I'm using this fixed delay retry, for instance, where the max retry count is 3, which actually means it'll try 4 times. It'll try the first time, which will be the initial time, and then it will try 3 more times, 4 in total. In addition to that, of course, once it fails for the 4th time, this will throw an exception because it'll say, hey, I give up. Now, the other thing I didn't mention is like when you throw an exception, that's exactly how these things know you failed. And a lot of frameworks work like that. So if I'm talking to people that have used a lot of frameworks, they're not going to be surprised by that. But every time this thing throws an exception, it's a fail. So you fail 4 times. Now, this retry is given up, but then what it'll do is the other one is going to kick in. It's actually going to re-queue it. It will bump up the queue, and then you're going to get another 4 times essentially here. So if it's going to re-queue it up to, like, say 5 times, which is the default, and you have set this set to 3, you can actually try it 20 times instead of what you're thinking might be 4. So, you know, that's fine. That's just a ramp up of understanding how it works. But I didn't like that as well. So you're completely able to go and just turn that other setting down to 1, so you don't get this kind of double type of retry thing going on. But by this point in time, I pretty much had it with this type of retry, and that's why you see it commented out. So what I'm using instead is the Azure Q Storage function retry mechanism. So how this thing works is, you know, if this is commented out, this thing starts to run, calls an API, it throws an exception, it fails, it'll immediately push it back onto the queue, and it'll bump up this thing called a queue counter, DQ counter, something like that, which keeps track of how many times it's failed. So I like that for a couple of reasons. 1, I like that it pushes it back onto the queue immediately after a failure. 2, I like that it keeps track of how many times it failed and puts it in the logs. There's a lot more observability there. A lot of things to like. So that is essentially what the style of retry that I'm using. So let me go to another file here, which kind of shows the magic of how to configure this. So you're going to see something here. It says max. This is the queue attributes essentially. Max DQ count equals 6. That means it will fail up to 6 times. And visibility timeout. So what this is, when you push a send, when you use like a send message type of operation to push onto a queue, you can also set, and anybody can do this, it's not limited to the retry mechanism. Anytime you call send message, you can optionally send something called a visibility timeout. And this is kind of what attracted me to the queues in the first place, even before I knew this existed. I was going to originally write a custom version of this retry. But what it does is it pushes it onto the queue, but it's invisible. You can't see it, which means it won't get processed for at least 30 seconds. So in this case, if it's 6 failures, I have 30-second visibility timeout, and you start failing, it will try it once, and then it will retry at the 30-second mark, the 1-minute mark, the 1:30 mark, the 2-minute mark, the 2:30 mark, and the 3-minute mark, of which point it will stop trying. And when it stops trying, well, then what it's going to do, I'm going to go back to the Azure Storage, is actually going to push it onto this thing called the poison queue. So if you're reading off live queue, something called live queue, it will create this thing called live queue-poison for you. Now, there's nothing on here right now, but if I was running my solution and it wasn't able to process it all the way if those API calls were failing, it would eventually stack them up into the poison queue. So once it gets into the poison queue, that's it. It won't try them again. So you want to make sure that, again, my demo settings of 6 retries and 30 seconds in between is more geared towards a developer wanting to see more instantaneous results, essentially. I don't want to be waiting for hours to see if it worked or didn't work or did put it in the poison queue. But productionalized settings would probably be a lot more duration in between, and probably a lot more tries, depends on how many tries you think is reasonable. And sadly, there is no exponential backoff for this type of retry. This is all you get. You get the max count, you get the visibility timeout, which is essentially equal to fixed delay. That's all they have. I didn't see anything else. So Microsoft, if you're listening, it would be great if you could add exponential backoff for setting the visibility timeout. Then you'd really have something. I still think you have something pretty good here. So that is the retry. Okay, so what we'll finish up with, we'll actually run the code, and it's not really too much to see here, but can't really do all this talking without actually doing a demo. So the first thing I'll show, maybe I'll just show here, I didn't show this part, but this is my emulator running over here. So let me just Control-C out here. This is Azurite. So all you do is you just go I just open it on the side. There's probably cooler ways to do it. I think maybe actually one time I think VS Code offered to start it up for me, so it might be hooked in. It actually knows that you're trying to hook up to it, I think. So there might be ways for the tooling to have it all integrated. But what all I'm doing is just opening up PowerShell and just running it. Now, the other thing you have to pay attention to, there's other parameters you can put here, which will say where you physically want to persist the files to or the data to, but you don't have to actually do that. If you just run it straight up, it's going to use the directory that you're in. So I have this directory here that I created, and that's where my stuff is, and I just go to that directory first, and then I just run it very quickly, starts up and running, and runs on these ports here, 10,000, 10,001, 10,002, presumably one for each service. blob, queue, and table in all likelihood, but I'm not 100% sure. So I'll just put that away. Now, again, like back to the having it run on VS Code is kind of good because I can run it and it knows it'll automatically knows to run the functions using Core Tools. So Core Tools is essentially, if you on the command line, you can take something like func and it will know how to run it. I've never actually tried to run the functions outside of VS Code before. I always just let it do it for me. So I'm quite dumb in that sense. I don't actually know how it works, but I'm glad that it's integrated into VS Code. Now, before I run, so I'll run basically the full flow, which means, back to this again, just to remind people what the full flow is again. Input file coming in, landing on blob storage, processed, chopped up into pieces, JSONized, put on a queue, and then for each queue member processed and an API called. So that's the full flow. That's your happy path. No errors happen. Now, so what I normally do is I come to my handy Azure Storage Explorer. Now, one thing that I haven't really coded for necessarily is, the management of it, like if the files will be coming in daily or whatnot, or on a basis just to know which one to grab. If I was using blob trigger, that would be easier because I just grab the latest one that comes in. I'm going to try to convert to a blob trigger in the future, but like I mentioned, there's a constraint I'm under. I'm not allowed to use it right now. So refresh. Yeah, so there's nothing in the live queue, poison queue, but my raw input file is here. So it always just grabs the raw input file. So every time, and it'll grab it every, so many minutes, as 5 minutes, I guess I have on the schedule, and push the flow through. So all I do is I basically just run and watch the output here. And because this is hopefully the happy path here, everything will just run perfectly, and it will very quickly process those 3 records. Oh, well, it has to do a build first. I notice it does a build even if I haven't made any changes. It does a clean and a build. I prefer that it not do that if it doesn't have to, because it takes a little bit of time to do the clean and the build, but I haven't quite figured that out yet. So it's starting to run. It's a little bit slow. As you can see, it's still doing the build. Now there's the func part. You can see those are my 3 triggers right there. And this is really the end of it right here. So this is the API getting called 3 times. It's already scrolled off. But essentially, it worked. Yep. So you'll have to take my word for it. So that's the full flow. Now I'm just going to let's see. Yeah, I'm just going to stop that for a second. So Control C to stop. Now the next test I'm going to run is I'm going to make that API fail. So you might have recall when I was talking about my mock API. I can show it again really quickly. My mock API, I have this thing called an error configurator. And what it does is it actually goes back into the blob storage, looks for this file called error config text, and it just sees if it's true or false, basically. And if it's true, then that means make it throw errors. It's a little bit backwards, I guess. Now, one of the cool things you can do in Azure Storage Explorer is you can actually live edit. So if I double click, it'll take a little while, but it'll eventually open an editor here. Now you see it's set to false. That means don't throw errors, basically. I'm going to set it to true. Oh, hell's going to break loose here. Save. Now, oh, this is great. So it goes, oh, you've changed something. Do you want me to upload it? Yes, I do. So now I've got that up in my container automatically. And when I restart, oh, another thing I'm going to do before I get too far here, I don't want this to take too long because it's a video, so we're going to set the, we're going to only retry 3 times, and it's only going to be 15 seconds between each retry. So, well, let's do 4 times. So that should be like after 1 minute, it will try that 4 times and it will give up. And then it'll actually push it to the poison queue, which I'll show you. Okay, so that's set up. I've made that a lot lower. I've turned my API on so it'll fail. And we're going to start debugging. No, I just run regular. The debugger does work, by the way. I haven't had much use for it with these little functions. Not too much can go wrong. So again, this is something I should probably figure out. I had to do another build. I did make a change though. So I changed a config file. So what should start happening? You should start to see stack traces like show up like crazy all of a sudden as it starts to fail. And hopefully it's not hung up. Every once in a while I found that it gets hung up. And that might be one of those cases here. Yep, I think it's one of those cases. I'm going to just retry this again. Oh, not that. We are going to try that again. Hopefully it works this time. Again, it's doing another build. Running the tests. Always important. Giving it a try. Hopefully it works a little better this time. And it's not. Okay, so we're going to try this again. What I'm attempting to do is run the code with the API configured to fail. It should attempt it to do it 4 times in 15-second intervals, and then it should give up after 1 minute, and it should put them in those 3 records in the poison queue. So there we go. There's some stack traces there. You can see it's returning a 503. That's after 15 seconds. So another 15 seconds should go by. Should start to see some more stack traces. There we go. And hopefully it's doing that for each of the records. So we'll just give it, that's the 3rd one. And 1 more. This should be the last one. If I try the poison queue now, it should be empty, but by the time this 4th stack trace comes again, there we go. Yeah, and there's the message. So I'm going to actually stop it right there. So you can see here it's actually signaled that the max DQ count of 4 got it to 4. It's moving to the live queue -poison. It did it 3 times, 1 for each record. And of course, if we go to here and we refresh, we will see these are the records it gave up on. So again, in reality, in a productionalized environment, you might have this set to try every 15 minutes over a course of several hours, or perhaps even a full day. It's hard to say. It depends on whatever you think is reasonable. Okay, so that's the second last test. Now, the last test I want to show is I want to run the same thing. So what I'm going to do is I'm going to clear the poison queue. Okay, now the live queue will be empty, as it should be. Now this time, I'm going to give myself a little bit more time. I'm going to put this back to 6 and 30. Okay. Now, I'm going to do the exact same thing that I did before. I'm going to start it up, and I'm going to let it fail a little bit. So we're going to see those DQ counts start to pick up, and then I'm going to quote unquote heal my API. And what you'll see is it'll actually process them. Actually, I'll change this to 20 seconds. There we go. A little faster. Okay, so here's the final test. We're going to run it just like last time. I still have a broken API, so we should start to see failures right off the bat. But I'm going to heal the API at some point in mid-course before they get a chance to go onto the poison queue. And the records will process. So there we go. We're starting to fail. We'll let that fail a couple more times, and then I'll get into the healing portion. I think I set 20-second intervals this time, so just to give myself a little bit more time. Okay, so there's a second bunch of fails now. So I'm going to open up my file. And I'll set this to false, which will make it work properly again. Upload, as per usual. Poison queue still empty. Okay, now I'm going to come back to here and watch, and there. And I'm going to stop it right there. So what you're going to see here is you're going to see that status code of 200, and you're going to see each of the IDs. So here's ID number. Here's the API successfully getting ID number 1, ID number 3, and there should be an ID number 1 here somewhere. Well, yeah, I'm having trouble finding it, but I'm sure that it's there. So essentially what happens is, things start working. It never gets into the poison queue. It fails at quite a few times. Now there's something called a DQ count, which I'll actually show you. You can see that it's starting to go up. Let me get this into an editor. So here, this is the DQ count for the first batch. So if you can see, I realize my mouse isn't working, but if you see the highlighted word, DQ count equals 1, I'm going to keep, here's DQ count number 2, DQ count number 3, 4, and then that's it. And then after it, but it was only going to have a couple more chances before it pushed onto the poison queue, but I healed the API. And when I did that, you can see right here, getting an API success for these records. Oh, and there's the one down there. So that's ID number 1 at the bottom. You can see it kind of like has them out of order here. 3 and 2. So that is the retry in full action, showing the recoverability of the system, how it could work in reality. I didn't really have too much else, so I hope you enjoy the video, and good luck with your Azure adventures, as I've definitely had some adventures just doing this demo. But at some point in time, I could be doing, or have someone else do a productionalized version of this, and hopefully all this investigation will pay off. So thank you, and have a good one.